Hi everyone. So in this video we will see file system gate PYQs. By the way, this is second video, okay, in the sense that we have already seen almost everything about the file systems, and which is in this video. If you do a Google search file system go classes, then you will see that video. I have just uploaded it 4 days ago, okay. So you can see this video, and this is 2 hours long video, and this is basically, in this video I have taught file system implementation from scratch, okay. So you can definitely watch this video, and if you already know the concepts, then you can directly follow this video, because here we are going to solve gate PYQs. But in this video I have already told all the concepts needed for file system and solve many questions, okay. As you can see, like, these are the slides from the previous video only. So solve many questions, and in fact I have solved many gate PYQs also. So just watch this video. All of this have been covered in the previous video, okay. So here we are going to solve a few more gate PYQs, and I can say, and few, or I think exact 15 more questions which are from weekly quiz, okay, which are from weekly quiz. So let's just start. Let's see this question. What they are asking in this question is that in the index allocation scheme of blocks to a file, the maximum possible size of the file depends on. So they are saying in inode kind of system, okay, in inode kind of system, the maximum size of the file depends on what? See, if you have inode, okay, then obviously one thing is there, that how many pointers this inode has, or you can say that whatever it is pointing to, okay, whatever it is pointing to, it may be basically pointing to someone else, right? So in other words, you can say that how many pointers, okay, this can hold, how many pointers this can hold, okay. So how to determine it? This will be determined using the block size and the block address size. So you can say this is actually equal to block size upon pointer size, right? So how many pointers this can hold, right? So this is one major, I can say, a major thing which will determine in the inode that what could be the maximum file size, right? How many pointers it can hold. And block size, so basically you can say, since it is depending on the block size and the pointer size, so these are the two things. So number of the blocks, uses for the index, and the size of the block. Yes, size of the block is one thing, right? Size of the block is one thing. And how many index block you have, right? So basically how many blocks you are using, okay. So yes, see, you can say that number of blocks that you are using for the index, this is just one block, okay. uh, so you can say that number of, see, given a block, you can say that number of pointers that this can hold, okay, multiplied by, assuming that this is directly pointing to some blocks, okay, multiplied by block size, right? I mean, number of pointers into block size, and this is just for one block, right? And then you can say into number of such blocks, right? Number of such blocks. So basically you can say that it will depend on the block size and number of pointers, basically, which means block size upon pointer size. So basically here the pointer size is kind of hidden, right? I mean, pointer size, it will depend on the pointer size. So you can say that pointer size छुपा हुआ है इसमें, right? Pointer size, I mean, the formula is block size upon pointer size. So pointer size is already there, okay. So it will depend on the pointer size, block size, and number of such blocks. So number of such means index blocks, basically. Okay, indexed. So you can say it will depend on size of the block, number of the blocks used for the index, and size of the address, which means size of the address means pointer size, okay. Size of the address means pointer size. Yes, it depends on the size of the address, number of blocks used for the index, and size of each block, right? So basically, see, let me just tell you, in index kind of system or an inode system, it will depend on that how many blocks you are using for the indexing, right? So number of blocks we are using for indexing, right? Definitely it depends on that. Multiplied by, for one block it will depend on the pointers there, how many pointers it can hold, right? How many pointers it can hold into, because these are the number of blocks it is pointing to, into the block size, right? So you can say number of pointers it can hold. I mean, it means one block can hold, right? One block can hold, multiplied by block size. Okay, now multiplied by the block size. Okay, so this is kind of rough formula, right? Obviously if it is even one more level of indirecting, then basically the thing here is that that whatever you do, it will depend on only on these three things, that how many index blocks are there, and for each block that how many pointers it can store, right? And obviously the block size. So how many pointers means it is basically address size or the pointer size. So these are the three things on which it depends: pointer size, block size, and number of blocks we are using for the indexing. So you can say that size of the block, number of blocks we are using for indexing, and the pointer size. So it depends on three things. A and B are kind of incomplete. Okay, A and B are saying size of the blocks, it is, yes, that is true. Pointer size, yes, this is true. But number of index blocks are missing here in A, right? In B, they're writing number of index blocks, size of the block is okay, but pointer size is missing, right? So C is complete. Okay, that's why C is the answer. Okay, now let's just move to the next question. So basically, hence option C is correct. Okay, yes, A and B are incomplete here. A and B are incomplete. Now let's see the next question. In the next question, they are asking the data blocks of very large file in Unix file system. Okay, this is kind of memorization question. So basically, you should know that in Unix file system, okay, in Windows they might be using FAT or anything, but in Unix file system we use index, in like multi-level indexing basically. Okay, so an extension of index allocation. See, each of this, let me just tell you, I have already told, okay, in the previous lecture, but immediately let me just revise that there are three major allocation strategies, but each is having one variation. So index is one thing, and multi-level indexing, it is another thing, which is extension of the indexing, right? So each is having one variation. So that's why there are, you can say, three. Okay, there are three. Okay, so yes, so basically they're asking in Unix which is used. So in Unix we are using multi-level extension, which is extension of index. So an extension of index allocation we use. So that's why D is the correct answer here. Okay, D is the correct answer. An extension of index allocation. So this is used in Unix file system. Okay, great. So answer is D. Now let's see this question. This question has been asked in GATE 2005, and like I have rewritten this question because this seeming like a big question. So I've rewritten this question, and this is the same question. I'm just rewriting it. So basically in this question they have given the four files. Okay, these are the four files they have given. Now they are saying that we want to store these files on the disk, right? I mean, they're not worried whether it is contiguous, whether it is fat, or whether it is linked or anything. Okay, they're just saying that we want to store these four files on the disk, right? Now they're saying to store the four files on the disk, you can either choose the block size to be 100 or 200 bytes, but not mix. I mean, it's not possible that you can for one file you can use 100, for another file you can use 200, or for one file even you can mix 100 and 200 like that, right? I mean, mixing is not possible for every data block. So let's suppose you are using either this or this, it doesn't matter. For every data block there is 4 byte of bookkeeping information that we need. Okay, the disk block can either store bookkeeping or the real file. So basically they're asking the total space used. So let me just give you quick glimpse that what they're asking, then we will solve this question. So basically they are saying that you want to calculate the total space used by, let's suppose, this file. Okay, they want to know the total space used by either 100 or 200. I mean, for both of the block size they want to know the total space, right? So so suppose for s1, okay, for s1, let's suppose this is these many bytes, okay, these many bytes of the data that s1 has. Now how much total space it will take? Let's suppose block size here currently I am taking 100 bytes. So two things you need to know, that total total data blocks, total data blocks, and another thing that you need to calculate is total bookkeeping blocks, bookkeeping blocks, and then you can sum both. Okay, so how many total data blocks you will be using? If each is 100, then you can say it will be divided by 100, so 110.50, which means it will be 11050 divided by 100, and then it will be seal means you need to take the upper part, so which will be 111, right? So you are going to take 111 blocks, data blocks, and for each data block 4 bytes of bookkeeping is needed. So that's why you can just multiply by 4. Okay, then you will getting 444 bytes. So basically these many bytes that you need for bookkeeping, so that's why you can multiply, or you can divide by 100. So see, bookkeeping bytes you can write separately, bookkeeping keeping bytes, which are 4 into 111, which is 444, these many bytes. So divide by 100, which is 45, right? 444.4, which is 45. So 45 blocks you will be needing. So 45 plus this will be total number of blocks for this file if you are using block size of 100. So see, you just need to calculate two things. Let me just directly show you the solution. Suppose we are using 100 byte, okay, 100 byte block, and in another case we will be using 200 byte block. Okay, so if you are using, let's suppose, 100 byte block, then two things are very important. Data block, how many data blocks you are using, how many bookkeeping blocks you are using, right? Data blocks you can easily calculate. If this much is data, then 111 are the data blocks. Then bookkeeping bytes are this. If these are the bookkeeping bytes, then bookkeeping blocks will be divided by 100, which is, okay, which is basically not 44, which is basically 4.44, which is basically 5, right? So total 116. Okay, total 116 blocks you will be using for this file. Okay, and in terms of the bytes, you can multiply by 100 again, then these many bytes you will be using. Okay, these many bytes. So similarly you just need to know data blocks and bookkeeping blocks. These are the two things you need to keep on calculating for all the files. Then you can calculate the total size by the summing up all this, then you will be getting this much is the total file, total number of bytes that you will be using if you are using 100 bytes of block. Similar calculation if you are using 200 bytes of block. Okay, bookkeeping blocks and the data blocks, bookkeeping blocks and data blocks. How to calculate? Divide by 200, right? Earlier I was dividing by 100, now divide by 200. So these many total bytes you will be needing to store all the files. So you can just add both of this. So okay, they are not adding, they are just asking individually. So these many bytes for 100 blocks, these many bytes for 200 blocks, I mean 200 byte blocks. Okay, so this is also a easy question, I can say. Let's now see this question. So they are asking, in which of the following scheme there is no external fragmentation? See, what is external fragmentation? It is basically, suppose you have some disk. Okay, suppose this is the disk that you have, and then you have many partitions in the disk, right? Many partitions, I mean these are the blocks. Okay, so external fragmentation says that suppose you have stored some file. Okay, some file, let's suppose you have stored here. Okay, some file you have stored, let's suppose here. Now suppose you want to store some file which needs 3 blocks, and let's suppose it is contiguous. I mean I'm assuming it is contiguous. Then contiguously you don't have 3 blocks, and if it is contiguous allocation, then this is the external fragmentation, which means fragmentation means wastage. See, I already told. See, in contiguous allocation, I already told in the previous lecture, in contiguous allocation you have the external fragmentation. Why? What happens if file C needs 2 sectors? Okay, suppose you have one sectors everywhere, but what happens if file C needs 2 sectors? You don't have contiguously, right? So basically this is like kind of fragmentation that you have. Okay, I mean you cannot store file C here. Okay, I mean, if you want to store, obviously you have to shift and you have to do some manipulation and all, but directly you can't store. So this is called external fragmentation. What is external fragmentation? That you have the external blocks, or you have the blocks and you have available blocks, but still you can't store, right, the file. But is this possible in linked or index? I mean, whenever, see, in both of this we use pointers, right? So whenever we use pointers, it is not possible. Why? Because in linked I can store one file here, I mean, one block here and another block here. Okay, because in linked you can directly link. Okay, similarly index also, you are maintaining index file separately, then you can directly point to these two blocks. So basically whenever you are using the pointer, then in that case this situation is not possible. Okay, so in linked or in linked or in index, this external fragmentation not possible for pointers, basically not possible because of pointers. But in case of contiguous, this is possible. So you can say uh, they are asking no external fragmentation, so you can say 2 and 3 only. So D is the correct answer here. Okay, D. Understood? Okay. So these were the gate PYQs that we had. Okay. Now let's do few questions from our quiz. So these are the questions, and I think there is one more gate PYQ that we will be solving at the end. Okay, we will be solving this gate PYQ after solving 15 more questions. Okay, which are from quiz, and these 15 questions are actually easy questions only. But let's just see these questions. Okay, and then we will solve one nice gate PYQ which they have asked very recently. Okay, so let us now see this question. So in this question they are saying that a system is using contiguous allocation. A file of size 100 blocks is already stored contiguously on the disk. So they're using contiguous allocation. A new block must be inserted at the beginning of the file, but the disk block at the start of the file is not free. So basically they are saying that if this is disk, then there are 100 blocks are already there which are occupied by the file, and they want to insert something at the beginning, right? But this beginning is not free, right? So obviously you have to move all of this here, and then you have to do it, right? So file cannot remain on this current location. So basically they are saying that this file cannot remain on this current location, you have to move it to somewhere, right? I mean, you can assume that you can move, you are just shifting it, right? Okay, so now assume that data of new block is already in the memory. So basically they are saying that that whatever you want to insert here, that is already in the memory. I mean, you don't have to read or write or something. The new block data is already in the memory, and the metadata, which is file control block, is already in the memory, which means that you don't have to from the disk, if this is disk, then you don't have to read file control block to the memory and all, so that you get to know the pointer to the first location of the first block or something. That is already, like, this is basically the metadata. Okay, the metadata is also already in the memory. Now, only reads and writes of actual file data blocks are counted as disk access. So, which means that you might be modifying the metadata, you might be, reading the metadata, or whatever you are doing with the metadata, or any other thing. Actually, this is not concerned for this question, and even we will be doing many more such questions. And in all the questions, I mean, I have written this line. If this line is even not written, then just assume that this is the default assumption for our questions. Okay, which means that we will be counting only the actual file, actual data blocks of the file. I mean, the metadata or other things, if they have to be adjusted, then we will not worry about it. Okay, so basically in terms of disk access, we will be counting only the actual data block files. Now they are asking how many disk read or write are required to perform this insertion. See, let me just put it very simply, that what they are asking. Okay, and then you will get to understand. So they are saying that you already have some disk where a file is already getting stored, and this file is already taking 100 blocks. Okay, suppose this file is already taking 100 blocks. So this is the file which is already taking 100 blocks. Now you want to insert, this is contiguous, right? Now you want to insert something at the beginning of this file. So you want to insert something here, but since this is occupied, so you have to shift all of this. Okay, shift 100 blocks to the right, to right. Okay. uh, and then this will be empty, and then you will be inserting, right? So whatever the new data, so this is, let's suppose, the main memory. Okay. And this is your disk. So whatever the new data that you want to write, that is already in the main memory. That's what the question is saying. Okay. So this is the new data block. Okay. So you don't have to worry about this new data. Like, I mean, you don't have to make any read or write access for the new data. I mean, you don't have to load this new data basically to the main memory. This is already in the new main memory. So this is the setup. So what we need to do, we basically need to sift all of this, right? So the first thing that we need to do is sift all 100 blocks. So let's see for the shift. Actually, we will be doing this in many questions. So for the shift, it actually needs two access. I mean, for the one block, it needs two access. Why? You will basically read it. Okay, read means you will basically bring this in the main memory. This is called read. Okay, I mean, you just can't do it directly here. You first bring this in the main memory. This is called read, and then let's suppose this is you are bringing here, then you write it here, right? I mean, wherever you want to write it. So basically, let's suppose you want to write it here, so you will be writing it here. Okay. So the thing here is that you first have to load this in the main memory, which is called read, and then you have to write it, right? So you have to, for shifting any single block. Okay, for shifting any single block, it takes two access. Okay. So for any single block, it takes two access. Two axes are needed, right? So if these are the 100 blocks, then you will be needing 200 axis, disk axis, which means 100 so writes and 100 reads. So basic two axis means here one read axis you first have to load in the main memory, and then one write axis, right? So basically two axes are needed. So for 100 blocks, 200 axes will be needed. So you can shift. So first action is to shift, and then once it is shifted, then you just have to write it here, right? You just have to write it here. I mean, you don't have to read this new data. So basically the second thing that you will be doing is just writing. Okay. The second thing that you have to do is just write the new data. Basically, you don't have to read the new data. So you can say the second thing will be just to write the new data. Let me just put a line here. So second, you will be doing write new block. So which means one write access. Okay. So hence 200 for shifting plus one for new data write. So 201 access are needed. Okay. So here you can see C is the correct answer. Okay. So C is correct. So you can say that for 100 block shift, 100 read and 100 write, 200, and writing new block is one more write access. So that's how you can solve this question. Okay, I hope you got to understood. This is easy question. I mean, at initial it might look tough, but once you understand that what is read and what is write, you will find it easy. So basically for shifting, you have to bring this in the main memory and then write it. Okay, so for every shift you need two access, one read access, one write access. So what you need to do, you need to shift all of this and then insert one here, right? So for insert, which means write, you need one more write access. So total 201 access is needed. So that's why C is the correct answer. Now let's go to the question number 2. Okay, in question number 2, they are saying the same thing, but here they are having the linked allocation, which means they are saying that you want to insert at the beginning, but here the data is using the linked allocation. So if you want to insert at the beginning of this linked allocation, okay, then in that case, what you see, this is the new data. This is in the main memory. You have the new data block, right? So obviously you have to write in the disk, and then you have to update the pointer, right? So what you can do, you can basically update. Obviously you can update the pointer in the main memory first, like where you already have this pointer because this is already in the directory or already in the metadata, right? So you already have the first block pointer in the linked allocation, and then you can modify this to here. I mean, this will be pointing here, and then you can write it, right? I mean, this modification doesn't need any read or write access because this new data is already in the main memory. So basically, the first step is to modify this pointer, which doesn't need any access, right? Modify pointer, but this is just within the main memory, so you don't need anything. And now you will be asking, so basically you have already modified, you will be asking it to, I mean, you will be just putting in the disk. So putting in the disk, you can put it anywhere, doesn't matter. Okay, so I mean, since it is linked allocation, it is anyway pointing to this, you can put it anywhere. So basically you can say the write, okay, just write. So just one write will be needed because modify pointer will not need anything. So you can say only one write will be needed. So A is the correct answer here. Okay, so only one disk access, so A is correct. Understood? See, so everything is written here, that update is pointer. Okay, I mean that is in the main memory, and then you have to just write it. Okay. Now the similar question is being asked. Okay, they want to insert in the beginning, but in this case you have indexed allocation, which means you have inode here. Okay, you have inode here, and then let's suppose this is the first block, this is the second block, third block. I mean, this is a pointer to first block, this is a pointer to second block, and so on, right? Pointer to third block. Then they want to say that they want to ask that if you want to insert it at the beginning, then how many read or write access will be needed? See, the data is already in the main memory. Okay, so you can just write it, and the address must be modified here, right? And then all of these pointers, see, now this will be the second. So once this is the first, okay, this is new, right? This is new. So once this is the first, this will automatically be the second, which means see, in the inode setting, what happens, let me just tell you, that the first pointer is always to the first block. So basically, let's suppose here something is written, and this is the pointer to first block. Okay, the whatever is the pointer, this is the pointer to first block always, this is the pointer to second block always, this is the pointer to third block always. So whenever you insert, which means obviously this have to be in the disk. Okay, you can put it in the disk, this is one write, obviously you need one write, but all of these pointers have to be shifted. Okay, all of these pointers have to be shifted below, and then this should point here, right? Now the thing here is that whatever you are doing, okay, here, that is within the main memory, because inode or the metadata is in the main memory. Okay, in main memory. So the pointer manipulations that you are doing in the inode is in the main memory. So you just have to write. I mean, just one write access is needed, and otherwise, like, you don't have to do anything. Everything is in the main memory. Okay. So the pointer manipulation is the main memory. So only one write will be needed. So you can say here A is the correct answer. Okay, answer is A, right? Answer is A. So just a second. Yeah. Okay. So see, you just have to write it and update the index block in the memory only. So zero disk access will be needed. Understood? Now let's see this question. In this question, they are saying that you want to insert between 50th and 51st block. Okay, and in the contiguous allocation, see, this is a contiguous allocation, and you want to insert. Okay, the disk is already storing your file of 100 blocks. Okay, this is the file of 100 blocks, and let's suppose somewhere here this is 50th block, this is 51st block. You want to insert between here, right? So if this is contiguous allocation, then you already know. See, let me write it little clearly. Suppose this is 50th block. Okay, this is 51st block. Suppose, okay, 50th. This is 51st. Okay, if you want to insert something here, then already you know the location of 50th block. I mean, there is no, in the contiguous you can just use the offset, which means if the one block size is, let's suppose, 4 bytes or whatever, then you know the starting, then you can do 4 into 50 plus a starting address. I mean, you can do some calculation, and you can easily get the 50th block location directly, right? Now, if you want to insert, then obviously these 50 blocks have to be shifted, right? So 50 blocks shift shifting is needed, right? shifting is needed. So for one shifting, as we know, two axes are needed. So basically, 2 into 50, which is 100 disk axes are needed here. 100 disk axes. Okay. And then once this location is empty, I mean this 51st location is empty, then the new data block have to be written here. So which means this is already in the main memory, so don't have to worry about it. If you write it, then this is one write for new data block. So you can say this is 100 for shifting plus 1 write. So 101 should be your answer. Okay, 101 should be your answer. Is this understood to everyone? See, 50 shift and 1 new write. That's how you can solve this question. Okay, so basically in this question they are saying contiguous is there, like in all the questions I'm just assuming 100 block size, and now they want to insert between 50 and 51st. Now suppose in the same situation, okay, they want to insert between the 50 after the 50th or 50th and 51st, but this is linked. Okay, so if it is linked, then if you want to insert, let's suppose this is the 50th and this is 51st. Okay, if you want to insert in between here, then obviously you have to first read all of these blocks. I mean, then only you can reach here. So 50 reads will be needed, right? Then only you can reach here. Now you must be asking this pointer, so basically plus 1, you can say 1 new write. I mean, you can write it anywhere, doesn't matter. So let's suppose I'm writing it here. Now you have to modify this, right? So which means you have to write it back. Okay, you have to write it back also. I mean, you have to modify this pointer and then it should be pointing here. Okay, so you have to write it back, and obviously whenever you're writing, you will be first making this. I mean, you will be basically already making this, right? So plus you can say plus 50th block pointer manipulation, which means one more write, pointer update, which means one more write. So 50 plus 1 plus 1, so which means C is the answer, 52. Okay, see, let me just tell you that what they are saying. If this is linked allocation, okay, suppose you want to insert between this is 50th, this is 51st. The first thing is that you have to read this pointer, right? So the step 1 is that this is your new block, right? New block. Here this pointer should be pointing to this, right? So step 1 is that you should be knowing that this pointer, I mean this address, then only you can update this here, right? Then only you can update this here. So you have to traverse these 50s. Okay, so traverse these 50s, get this, and then update it. So basically, I mean, this is in the main memory, so you don't have to do anything. And then traverse 50, so 50 read, then you update it. That update in the main memory doesn't require any access. Then you write in the disk, right? Plus 1 new write. Okay, then interestingly you also have to modify this, right? This pointer, I mean, wherever you are writing it, you also have to modify this pointer. Plus 50th block pointer modify. Pointer modify means you have already read it, right? Then you have to write it also. Okay, I mean, you have already read all of these, so now you have to write it also. See, you have to read one by one. So basically if these are the 50 blocks, okay, so let's suppose this is the block number 1, block number 2, you will be first bringing this in the main memory. Okay, read this, and then because of this pointer, you will get to know what is the next location. Then you read this in the main memory. Okay, then because of this you will get to know what is the next location, then you read this in the main memory, and so on and so forth, right? Now once this is 50th block, okay, once this is 50th block, then you will bring this also in the main memory, right? So 50 traversal, 50 reads are needed, and then you get to know that, okay, what is the address of 51st, right? Then you update this address in the new block, and you know the whole story, right? And then you also have to update this. So since you have to not only read, this is the read, but you also have to write it back. Okay, this block must be written back also, because you are updating this pointer. So that's why you need one more extra write for, I mean 50 reads are okay, one new write, and then one write for this also. So that's why 52 is the answer, not the 51. Okay, Now let's see this question. So in this question they are saying that you again want to insert after 50, but you are having inode. Okay, if you are having inode, okay, then let's suppose index to first, index to second, index to third, and so on. If you are having inode, then what will happen? Tell me. You have to basically, if you have to write, then you have to obviously write one new write, okay, and then you have to modify all of these pointers. I mean, all of these pointers have to be shifted below, and then this should be updated to the new, but all of this is in the main memory, right? So these pointers manipulation doesn't require anything. You just have to write one thing. So that's why this is one access you need, right? So you just need one access, one write access. Okay, I hope you understood, because just new block must be written, that's all, right? All the pointers manipulation is in the main memory. New block must be written, and all pointers update, pointers manipulation is in main memory. Understood? Okay, now let's see this question. Consider a file. See, you what you can do, you can just pause this video and you can just try to solve by yourself. Okay, so they are saying consider file stored using the contiguous allocation. Now they are saying a file occupies 100 blocks and free space exists immediately after it. The new block must be appended at the end. Okay, this is contiguous and new block must be appended at the end. The new block data is already in the main memory, then how many disk access are required? So see here, see this location is already empty. You can write new, right? You can write new directly. Then what else you need? I mean, you already know the location of this. You can directly write it here. What else you need? I don't think you need anything else, right? So only one access should be required. Let's just see the answer. Yeah, one disk access, right? I mean, you might have to update that. Okay, this block is basically earlier it was free, now it is occupied. You might have to update these metadatas, but that's not important to us, because only the actual block read or write will be considered. Okay, so whatever extra things that you have to do, let's not worry about it. Okay, in all the questions, whatever extra things you are doing, let's not worry about it. So that's why only one access is required. Let's see this question. In this question, they are saying again the same thing. You want to insert at the end, and it is linked allocation. So in the linked allocation, if you want to insert at the end, then you obviously have to know that. I mean, see, you have to basically go here to modify this. I mean, ultimately you have to modify this, right? So the 100 traversal will be needed. I mean, you have to read all of this 100. Now, interestingly, you have to write this also back, right? I mean, you have to write this for sure. You have to write this also, because the pointer have to be modified. So what is the answer here? 100 traversal plus one new write plus you have to write this also, right? Plus 100th block pointer manipulation. That's why you have to write this also. So basically you can say 102 should be the answer, right? So basically okay, so this new, if you are writing it, so these are the 100 traversal, 100 read plus one new block write plus 100th block write because of the pointer manipulation. So total you can say this is 100 reads, one write, and then one more, right? One more, right? So 102 access, disk access are required. So that's why C is the correct answer. So you can say answer is C. Okay, so this was question number 8 and answer is C, 102. Now let's see this question number 9. Consider a file stored with 100 contiguously. Okay, so they are storing contiguously this time. Removing the first block requires the shifting of remaining 90. So basically they want to remove. Okay, So they want to ask that how many disk access are required if you want to remove the first block. Okay, suppose these are the 100 blocks, and if you want to remove this, so you need to shift. Okay, so shift means 99 block shift means 99 to 198 access are required here. Do you need any other access? See, you might have to update some metadata that okay, now the starting position, or maybe now the length basically has been reduced to 99 and all, but only we are concerned in all of the questions. Although I have not although I have not written explicitly in this question, but I will write it later on. I mean, if that is required. But in all of these questions, just assume that only actual data file read or write access are basically asked. So 99 shift are only needed, right? So you can say 198 is the answer, because you just need to shift 99. Okay, 198 is the answer. So A is correct. A is the correct answer. Now let's see this question. So they are saying that we want to remove the 50th block in the linked allocation. Okay, so which means that if there are 100 blocks, let's suppose this is the 50th block. Okay, suppose you want to remove this. Okay, this is the 50th block. Then basically ultimately we want to point from here to here. Okay, that's the ultimate aim, and then we will mark this block as free block, which is like metadata update or something. Okay, like there is a free list or something, we are not concerned about it. The main thing is that we want to basically modify this pointer from here to here. So we have to know the address of this, which means we have to know this, because that's where the address of this is required. So that's why you can say that you have to basically traverse till this point. I mean, you have to traverse till this point. 50 traversal will be needed. Okay, if this is 50th block, so 50 traversal will be needed. Okay, from here to here, because ultimately then only you can get this. Then you have to 50 traversal means 50 read. Okay, so you already read it. Now basically you have to write this also. I mean, there is one more write also that is required, because here the pointer manipulation is also needed. So 50 reads plus one more write. I mean, you have to read it also, which is already counted in this 50 reads. Okay, so 50 reads where I am already counting this, and then you have to write this also back, because this pointer has to be manipulated. So 50 plus 1 and 51 should be the answer. Okay, so to delete 50th block, the linked allocation required a sequential traversal. We must access 49 blocks to reach the block 49. Then we access 50, then we finally update the block 49 and so on. Okay, so basically I hope you understood. This is the same thing that we have told, and I think I told in the easier way than this text. So basically you have to, let's suppose this is the 50th block. Okay, you have to ultimately do from here to here. So which means you read all of this and then one more write. Okay, so 50 reads and then one more write, so which is 51. Understood? Now let's see this question. Consider a file that is stored using the linked allocation. We want to remove, okay, in the linked allocation they want to remove the first block. Okay, so they want to remove the first block in the linked allocation. So I think this is easy only. Basically in the metadata, what you need to do, you need to basically, if you want to remove this, then you need to update the pointer to here directly, right? I mean, this is the first. Now the first will be this one in the metadata. The first will be this one, but you don't know the address of this. So this address will be known to you if you read this. So read this, then only the address will be known to you, and then update the metadata. Read this and update metadata. And metadata update is not basically counted as a disk access. Okay, I mean in this question at least. So read this, which means one read access will be required. Only one read access will be needed. So that's why you can say A is answer. Okay, so A is answer here. Understood? Let's see this question. What they are saying. Consider a file using the single level. So basically this is inode, single level inode, and 100 blocks and the inode that is already in the main memory. Then you want to remove the first block. This is interesting. If you want to remove the C, let's suppose this is the pointing to first block, this is pointing to second block. If you want to remove this, then you have to shift all of these pointers up. And what else you need to do? Maybe you need to mark this particular position as free, which is the updating metadata and all. But yes, all of these pointers should be up, right? You don't have to do any read or write access. You just, I mean, whatever you are doing, that is in the main memory. Okay, so just shift all of this up. That's all is needed here. So that's why you can say the 0 disk access are required. Shifting the pointer is in the main memory. Okay, so 0 disk access are required. So again, A is answer. I hope you understood. Okay. Now let's see this question. What they are saying: a file is stored using contiguous allocation. Okay, block positions are numbered from 0 to 99. Okay, there are 100 blocks and 0 to 99 are the block positions. We want to remove the block at position 50. So basically, if you want to remove the block at position 50, which means block at position 0 means the first block. So which means they are talking about the 51st block. 51st block. Okay, 51st block they are talking about. So they want to remove in the contiguous allocation, they want to remove the 51st block. Okay, so basically, let's suppose this is the 51st block. Then what they're saying, then it will be shifted. Okay, so all of these should be shifted left. Okay, all of these should be shifted left. So these are the 49 here, 49 blocks here. So 49 shifts are needed, shifts. So which means 49 into 2, 98, right? 98 access will be needed here. And what else they are saying? So what else you need to do? See, you have to shift all of this here. That's all, right? And you don't have to do anything in terms of the read write disk access. I mean, in terms of the actual file data read write access. So 98 access you have to do. So that's why C is the correct answer. Okay. See, the only thing that I want to convey here is that this is, they are talking about 51st block. Okay, not the 50th block. It is clearly mentioned that block number are 0 to 99 and they want to remove the block at position 50 and block positions are numbered from 0 to 99. Okay, great. Now again the same thing, they want to remove the 51st block in the linked allocation. Okay, so they want to remove, let's suppose this is the 51st block. Then basically these are the 50 blocks here. You have to read all of this. Okay, and then you have to read this also, because then only you get the pointer to in the next thing, right? So basically ultimately your aim is to do this, right? So read all of this, read this also. So 51 reads, plus you also have to write this back. Okay, you don't have to write anything else back, but you have to write this back, because once you get the pointer of this, you have to write this back, right? Plus 1 write. So you can say 52 access will be needed, 52 access. Okay, understood. So which means C is the correct answer here. Now let's see the next question, which is the last question of this quiz. So this was a quiz of 15 questions and this is the last question of this quiz. So they are saying that if you have linked allocation and you want to remove the last block. Okay, let's suppose this is the last block and these are the 100 blocks. So which means this is the 100th block. In the linked allocation, if you want to remove this, then what are the read or write? So you can say that you have to read all of this and then you can just directly make this null, right? I mean, basically you have to read 99 reads will be needed, plus one more write to make it null. Okay, plus one write to make it null or end of file, right? For end of file. So basically 100 will be needed. So again, C is the answer, which is 100. Okay, update null. Understood? So that's how you can solve these questions. So these were the easy questions. We had a quiz here, which were 15 questions quiz. Okay. Now let's solve this question. This question was asked in GATE 2022 and this question was actually based on the similar concept. So basically Basically, let me tell you what this question is asking. They are saying that you have two file system A and B that uses contiguous and linked. So basically, they are asking for contiguous and linked both. Okay. A file of size 100 block is already stored in A and also in B. Now consider inserting a new block in the middle between 50th and 51st block. Okay. So they are saying that in the contiguous also you want to insert between, this is 50th and 51st block. In the linked also you want to insert between 50th. Let's suppose these are the 50th and 51st block. Okay, whose data is already available. So new block data is already available in the main memory. Assume that there are enough free blocks at the end of the file that okay, that's fine. Let the number of disk access required to insert the block in the middle. So basically they are saying, suppose here if you want to insert, then number of the disk access, the NA, this is NB, and then they want to find the summation of NA and NB. Okay, let's just find it out. So if you want to insert it here, okay, then obviously you have to sift all of this, right? You have to sift all of this. So 50 sift, so you can say 50 sifts are needed, and then one write, right? So like ultimately you have to write the new block, one write must be needed. So you can say 100 plus 1, 101 access will be needed here. So NA is 101. What about this? If you want to insert something here, so all of this you have to read. Okay, so 50, you can say 50 reads. So ultimately, if you want to insert, so basically this should be pointing to the new, right? And then this should be pointing here. Okay, so you have to basically write the new block plus one new write plus one write for the pointer manipulation, right? I mean, you have to basically do the pointer manipulation, which means you have to update this. So one write. So here 52, here 101. So they are asking basically NA plus NB. Okay, so NA plus NB will be NA plus NB will be 101 plus 52, which is 153. Okay, so you should be trying this question, and then the final answer is 153. Understood? So this was easy question once you understand the concept, about this, that how to modify any file using contiguous, linked, or something, and how to count the read or write accesses. Okay, so 153 is the final answer for this question. So that's all for this video. I hope you understood the this read write access concept. Okay, so thank you everyone. If you have understood everything, just let me know in the comments that you have understood everything. Okay, thank you.